So let's say we have a particle that is forced to live in a one-dimensional region, let's say between 0 and d. And the mass of this particle is m naught, and we want to compare with another particle that is forced to live in some region, the length of which we want to determine. Its mass is 10 times m naught, but we want its energy values, its energy levels, En, to be the same. So En, we know, is n squared h squared over 8m times the distance squared. Let's call that L squared. So we have, for this system, we have that's n squared h squared over 8m naught d squared. And what we're saying is that that must be the same for the other particle. And therefore, we have 8. This is going to be 10 m naught, so we get 80 m naught. And we want to find what this is, so this is the unknown, L, and we'll find what L is in terms of d. And so what follows from this is that we solve for L. And so we're basically flipping this. And so we get that L needs to be smaller than d. We have to take the square root. And so L ends up being the square root of 8 over 80 d, which is 1 over the square root of 10 times d. So L is about a third. L is about d over 3. So in order for the more massive object to have the same energies, we need to constrain the particle more.